properties, they're very closely related to exponentials. Because we know logs and exponentials, you can go back and forth between the two. So that's why their properties are similar. If you think about this one, I said if you have the log of things being multiplied, you can add each individual log. Think about if you have exponents. If I said 2 to the third times 2 to the fourth. So I'm multiplying with those. What do you do with the exponents? Add them. And remember, a log is really just that missing exponent. So that's why those are added. If I said 2 to the 10th divided by 2 to the 4th, what do you do with your exponents? Subtract them. Well, so if things are divided, those logs really just represent the exponents, so that's why we're able to subtract them. Does that make sense? The power property is a little less obvious. If I said...
Did you mean you put 10 minus 4?
Yes, I did. Thank you. Log base 3 of 5 squared. Or let's not do 5. Let's do 9. Okay, if I asked you to simplify that, okay, if you turned that, set it equal to x, then if you change it to exponential form, you get 3 to the x equals 9 squared. So you would get a common base. 9 is 3 to the second. And so you end up with x equals 4. So what we really ended up doing with this exponent here is we took the log of the inside number and then we got that times 2. Okay, that exponent would just trail along and be multiplied ultimately in the end. So that's why we could, at the very beginning, bring it down and then multiply. So you're not going to have to justify these properties to me at any point, but what I want you to understand is they're not just made up, it's all due to the exponent laws that we already know, because a log is just finding a missing exponent, so it has the same properties as those exponential functions. So let's take a look at, sorry, I thought it was from yesterday. There is a handout that I posted on Classroom. I would like for everybody to pull that up. We are not going to do all of these, but these are some of the examples that we are going to work out. So if you could please open that up. Just be expand or condense. Expand meaning break all this stuff apart. Condense meaning turn it back into a single logarithm. So for the first question, anytime there's not a base written, it's understood to be a 10. It could be any base here, just to keep things simple. I did not include those. If you have 6 times 11, how would I expand that logarithm?
Log 6 plus log 11.
I'm not asking you to evaluate or anything. I'm not asking for a final answer. That is the expanded form. That's all I need you to write. All right, let's look at number 3. A couple different starting points. What should I do about that 5th power? It comes down in front. So that's 5 times the log of 6 over 11. And we can break apart the log of 6 over 11, can't we? How does that separate?
Log 6 minus the log.
I kept that 5 out in front because everything was to the 5th power, so the 5 really applies to all of them. You could certainly distribute that if you would like. You could write 5 log 6 minus 5 log 11. I do not care. But that exponent was applying to both the 6 and the 11, so it needs to be in front of both. number 7. How would we write this?
Log x minus log 6.
So if things are divided, you do the log of the top minus the log of the bottom. Then, what do we do with that exponent? It doesn't go in front of everything because not everything was to the 6th power. So it's log x minus 6 log y. Let's look at 11. A cube root is like what power?
3 squared, or 2 thirds.
So I could write that as a 2/3 power. Then where would I put that?
Front.
So we have 2/3 times the log of those 3 things. But since they're multiplied, we could break that apart. So that would be the log of x plus the log of y plus the log of z. Okay, you don't have to just be breaking apart 2 things. It can be as many as I want. And each one just gets its own log added together. Are we okay with these expanding? Let's try some condensing, going the other way. So if I look at, let's go to number 17. What would you do? We have log 7 minus 2 log of 12. What do we do with the 2?
It's the exponent.
And that's just the exponent on the 12. So when I condense, I only want one log written. 7 over, since it was subtracted, it'd be over the 12 squared. So it's log 7 over 12 squared. What about 19? What do we do with that 6?
It's exponent of u.
We have log base 3 of u to the 6 plus
Log 3 b to the 6.
if these logs are added, how do we put them together?
Multiply.
That's log base 3 of u to the 6 times b to the 6. All right. Do you guys have any questions so far?
No.
Okay. So I'm going to put a few more up here.
about 18 on here?
Yeah, let's do it. So 18. All right. This one is written kind of strange. 2 log 7 over 3. You could rewrite this as 2 over 3 times the log of 7. Now if we do that, what do you do with that 2/3? So it's log of 7 to the 2/3 power. Thank you for mentioning that one. All right, any others on this handout that you guys think we need to look at?
What's in, like, IN?
Oh, LN is just a natural log, so just like any other log. Okay. So if I ask you to expand, what does that mean? Yeah, we're breaking them apart. Okay. So can we do some harder ones now? Yes. You are not just going to sit there. Let's say I gave you. Okay. How many logs do you, how many times will I have to write the log at the end?
2, 3.
Well, I'm just gonna keep guessing numbers.
6.
Expanding, we break it apart, right? So if you have things divided, you have to subtract them. So it would be the log of the top minus the log of the bottom. We agree with that? Now on the top, if I have things multiplied, can we break that apart? Yes. So we can do, each one, sorry, should get the log base 2. So you do log base 2 of the first one, plus log base 2, the x plus 1, minus, what can I do with this one?
3 log.
Okay. So we've got 3 logs written so far. Can I break apart when you have the log of things being added? Our properties that we wrote down yesterday said we can break it apart if things are multiplied or if things are divided. So can we separate them if they're adding? No. So that's our final answer. That is as far as we can go there. Let's say I gave you all right. So what would we do here?
Subtracting.
So we have log base 3 x to the 7 minus log base 3 of this 2 times x minus 3. Now, as you get more comfortable with these, you may not have to show every single step. That's okay. So what do we do with the first one?
3 log.
The 7.
Oh, yeah, 7.
So 7 log base 3 of x minus, what do we do here?
So distribute the two.
Okay. You could multiply the 2 through. I'm going to go ahead and just break it up into individual logs. This is one thing that sometimes gets people. Keep in mind, we're subtracting off this entire log, right? So even though these things are multiplied, and you would have to turn it into log base 3 of 2 plus the log base 3 of x minus 4, since I'm subtracting all of that off, what happens to both of those? What kind of sign would they both have? A negative. Basically, anything that was on the top of your fraction should have a positive coefficient. Anything that was on the bottom should have a negative coefficient. Okay, and so you might end up subtracting off multiple things. Can we break apart the x minus 4? No, so we're done. All right. Are those okay?
Yep.
Let's do a couple more condensing ones. Let's do, say we do the natural log of x. So when I look at this one, I have a coefficient of 3. So what will that turn into? That's going to go into the exponent. You're only writing the log once. So we have things added, we have things subtracted, so we're going to get a fraction. Basically, anything that's a positive coefficient is on top, anything negative coefficient is on the bottom. So the x will be on top. The 9 will be on, so you can write it as x times 9, I'm going to put 9x. Minus, so this one goes on the bottom, and it would be a 5 to the 3rd. Minus, so this is on the bottom, x minus 1. Alright, let's say I gave you So if we condense, that means the log base 4 is written one time. Since I have some plus and some minus, we know we're getting a fraction here. Is the A on top or bottom? Top, because it's a positive in front. Minus, so this will go on the bottom. B to the 3rd, good. Now I'm back to a plus. If it's plus, where does it go? So that would put a 7 on top. Minus, so this is on the, and that would be,
3 plus 2 to the 2nd.
do we need more of these?
So if it's not going to be a fraction, they're all going to be the same. Like, let's
They would all have to be positive to not be a fraction. If they were all negative, it would just be 1 over all of that stuff.
Okay.
Okay, Okay, so there is a math Excel assignment. A lot of the questions are like yesterday's stuff, so kind of reviewing that. And then the last few are dealing